Welcome to Mathmaxtra. This is Saritha. Today our topic is factorization of an algebraic expression. First, we will know what is a factorization. What is factorization? Factorization is nothing but if you have an algebraic expression, we write that algebraic expression in such a way that it is a product of two algebraic expressions. So we are writing an algebraic expression as a product of two algebraic expression. Then we call that as a factorization of an algebraic expression. Okay, I take one example. So our example is 3x square plus 6xy. Now you see what is common in these two terms. It is an algebraic expression first. Okay. Now we are writing this algebraic expression in such a way that it is a product of two algebraic expressions. See what is the common in this? 3x is common. So what remains? X plus 2y remains. Okay. Now these 3x and x plus 2y. What are these two terms? These two terms are also algebraic expressions, but we have written it in such a way that it is a product of two algebraic expressions. So this we call it as a factorization of an algebraic expressions. And these individual terms, after writing as a product, these two terms we call them as a factors. What we call these? These are factors of an algebraic expression 3x square plus 6xy. Okay, this is a factorization of an algebraic expression. So what is a perfect square? An algebraic expression which can be expressed as a product of two same algebraic expression. Then we call that as a perfect square. See one example. 16x power 4. How can we divide it into product of two algebraic expressions? Two same algebraic expressions. 4x square and 4x square. So, what we have done here? This is an algebraic expression. We are writing this as a product of two same algebraic expressions. That is why we call this algebraic expression as it is a perfect square. Okay. What happens if a binomial is multiplied by itself? Means how many terms does the product of two same binomials contains? How many terms? In the yesterday class we have seen that if you multiply two binomials, that the product of the two binomials need not be 4 terms, isn't it? Now if we multiply binomial by same itself, see I am taking one example, 2x plus 3y. Okay, so this is a binomial. I am multiplying this binomial with itself, means we are multiplying again this with 2x plus 3y. Then the product of these two binomials contains how many terms? Now we will see. This is like a plus b into a plus b whole square. So obviously it contains how many terms? 4x square plus 12xy plus 9y square. So it always contains 3 terms in the product, isn't it? But in the case of two different binomials, so that product may or may not contain exactly 3 terms. We can't say exact number of the terms. But when you take the case, the binomial is multiplied by binomial itself, same binomial, then the product always contains 3 terms, exactly 3 terms. Okay. What is an algebraic identity? So an algebraic equation. So if you take an equation, if it satisfies for all real values of variables, then we call that equation as a identity. See, you take this example, x plus 2 is equal to 0. This is an algebraic equation. Now tell me whether it is an identity or not. So as I said, identity must satisfy for all real values of x. Okay, I am taking x value as -2. So will it satisfy? Yes, -2 plus 2, 0 is equal to 0. Okay, it's satisfied. If you take x value as +2, what happens? 2 plus 2, 4 not equal to 0. Isn't it? Means it is not satisfying for x is equal to 2. Okay, so that is why this is not an identity. Identity is nothing but it should satisfy, no, for all real numbers. Then only we can say it is an identity. See, x plus y into x minus y, which is equal to x square minus y square. So, does this equation satisfy for all real values of x and y? If you can check, yes, this satisfies for all real values of x and y. That is why we can say this is an identity. Okay. So, we will discuss some basic identities, some basic algebraic identities which are helpful while solving the questions easily. Okay. The first identity is nothing but a plus b whole square, which is equal to. So what is a plus b whole square means? Means we are multiplying a plus b with again a plus b. Now in yesterday class we have seen how to multiply two algebraic expressions. Yes. So what we have to do? First we have to multiply each term of an expression A with each and every term of an expression B, isn't it? So now I am doing the same thing. A into A. What is A into A? Which is A square. Next A into B, which is AB. Next B into A, which is BA, plus B into B, B square. As we can multiply, if A into B or B into A, the value remains the same. That is why we can write it as it is 2AB plus B square. Okay. So our first identity is what? A plus B whole square is equal to A square plus 2AB plus B square. Okay. Second identity is A minus B whole square is equal to. Now here we are multiplying A minus B with A minus B. See, first you multiply A with A, which is A square. Now A plus into minus, minus A into B, AB. Next minus into plus, minus A into B, again AB. Minus into minus, plus B into B, B square. So which is simply A square minus 2AB plus B square. Okay. So our second identity is A minus B whole square is equal to A square minus 2AB plus B square. Okay. Now if you add these 1 and 2, what happens? A plus B whole square plus A minus B whole square. What is A plus B whole square value? Which is A square plus 2AB plus B square. Okay. And plus A square minus 2AB plus B square, right? So A square minus 2AB plus B square. So what is the sum of these two? If you cancel 2AB minus 2AB, then 2A square plus 2B square, which is nothing but 2 into A square plus B square. isn't it? So how can you write a plus b whole square plus a minus b whole square is equal to simply 2 into a square plus b square. So our third identity is a plus b whole square plus a minus b whole square is equal to 2 into a square plus b square. Okay. And our fourth identity is if you subtract these two equations, these two identities, what happens? A plus b whole square minus a minus b whole square, which is, see, a plus b whole square is a square plus 2ab plus b square. And what is a minus b whole square? A square minus 2ab plus b square. You subtract these two identities. What happens? Change the signs. Minus plus minus. These two are gets cancelled. These two are gets cancelled. So which is simply 4ab. Isn't it? So what happens? A plus b whole square minus a minus b whole square, which is equal to 4ab. Okay. So this is one identity. If you write this as a minus b whole square minus a plus b whole square, what happens? We have discussed this in the properties of subtraction. If a minus b, if we calculate a minus b, what will b minus c? B minus a, simply it is minus of that expression, right? So this is like a and b. A minus b is, we got this 4ab. So what is here? B minus a, which is minus of that expression, right? That is why, which is simply minus of 4ab. Okay, so these will help you while calculating the problems easily. Means if the given question, the given values are in this form, we can directly apply this identity and you can get the answer easily. Okay, we know a plus b whole square is equal to a square plus 2ab plus b square. Now what will be a square plus b square? You take this 2ab for left side. What happens? Which is simply a plus b whole square minus 2ab, right? So this is one identity. What is our sixth identity? Which is a square plus b square, which is always equal to a plus b whole square minus 2ab. Okay. If you take a minus b whole square, which is nothing but a square minus 2ab plus b square. Okay. So if you write a square plus b square here, what happens? A minus b whole square, and you take this minus 2ab here, which is plus 2ab. So this is one identity, which is nothing but a square plus b square is equal to a minus b whole square plus 2ab. Okay. So sometimes we have a value of a minus b. So and ab values, a minus b, ab values are given. Then you need to calculate sum of the squares of a and b. Yes, which is nothing but a square plus b square. So that time this formula will help you. Okay. Our next identity is a plus b into a minus b. A plus b into a minus b. How can we multiply a plus b with a minus b? Simply a into a square minus a into b ab and plus a into b ab plus into minus minus b square. So what will remain? A square minus b square, right? So our next identity is a plus b into a minus b, which is equal to a square minus b square. Okay. What is a plus b whole cube? So how can you write a plus b whole cube? You can write this as a plus b whole square into a plus b. Isn't it? Bases are equal. Exponents you can add, which is nothing but a plus b whole cube. Okay. So now you know a plus b whole square value. What is it? Which is a square plus 2ab plus b square, and it is multiplied with a plus b. You simplify this, which is a square into a cube plus into plus a square into a square b plus into plus 2a square b plus 2a b square plus b square a plus b cube. Now you simplify. A cube plus a square b 2a square b. So 3a square b plus 2ab square b square a, which is nothing but 3a b square plus b cube. So this is other identity which is equivalent to a plus b whole cube. So what is a plus b whole cube? Simply a cube plus 3a square b plus 3ab square plus b cube. Okay. You can calculate a minus b whole cube value. What is a minus b whole cube? Which is a cube minus 3a square b plus 3ab square minus b cube. And from this identity, you can write a cube plus b cube. Okay. So how can we write a cube plus b cube, which is equal to, if you take these two terms this side, what happens? A plus b whole cube and this minus 3a square b minus 3ab square. If you take 3ab as a common, 3ab as a common, so what will remain? A plus b, isn't it? So how can you write a cube plus b cube, which is a plus b whole cube minus 3ab into a plus b. Sometimes we have values of a plus b as well as ab. So that time you can simply calculate a cube plus b cube value. Okay. And from this expression, what is a cube minus b cube? See, a cube minus b cube. You keep these two terms this side and take the remaining terms this side. What happens? A minus b whole cube and this minus 3a square b will become plus 3a square b, and this plus 3ab square, how can you write a cube minus b cube, which is equal to a minus b whole cube, and take these two terms this side, which is plus 3a square b and minus 3ab square, right? Now you take 3ab as a common. What remains? A minus b. So instead of this, you can write this. Okay. Which is, now a cube minus b cube is equal to a minus b whole cube plus 3ab into a minus b. See, if you know a minus b value and ab value, you can simply apply a cube minus b cube formula. Then you will get answer easily. Okay. Our next identity is, from this you take this identity. In this identity, a plus b is there. Here also a plus b. You can take a plus b as a common. You see, if you take a plus b as a common, okay. So what is remain in this term? A plus b whole square, right? Which is a plus b whole square, and in this term minus 3ab remains. So minus 3ab. Okay. Now you simplify this, which is a plus b into, we know a plus b whole square value, which is a square plus 2ab plus b square and minus 3ab. So what happens? Plus 2ab minus 3ab, which is a square minus ab remains plus b square. Now, and this a cube plus b cube can also be written like this, which is equal to a plus b into a square minus ab plus b square. Okay. And how can you write a cube minus b cube? From this equation, if you simplify like this, if you simplify like that, you will get a minus b into a square plus ab plus b square. Our next identity is a plus b plus c whole square. How can you calculate this? We know a plus b whole square format. So we can write these 3 times as a 2 terms, which is, let us consider this a plus b as a 1 term and this c as a 1 term. Now, which is like a plus b whole square, right? So how can you expand this? A square. So in place of a, we have a plus b whole square. Okay, a square plus 2 times of a into b, right? In place of a, we have a plus b, and in place of b, we have c, right? 2ab plus b square. So in the place of b, we have c, right? C square. Now you can simplify. A plus b whole square, you know. A square plus 2ab plus b square plus 2ab, 2a into c, right? 2ac plus 2bc plus c square. So what happens? A square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay. So this is what we got for the value of a plus b plus c whole square. This we can also write a square plus b square plus c square plus, if you take 2 common, ab plus bc plus ca. Okay. If you want to calculate a square plus b square plus c square, if you want to calculate a square plus b square plus c square, what happens? You take this term on this side. A plus b plus c whole square already is there, and you bring this term to left side. What happens? Minus 2 times of ab plus bc plus ca. Okay. So if you have sum of all a, b, c and sum of the product of two terms AB plus BC plus CA. If you have these two terms, you can calculate A square plus B square plus C square. So this is one more identity. Our next identity is A square plus B square plus C square minus AB minus BC minus CA, which is equal to half of A minus B whole square plus B minus C whole square plus C minus A whole square. If we know the difference of any two terms, then you can calculate this value easily by this formula. Okay. If a plus b plus c is equal to 0, how can you write this? A plus b is equal to minus c. Okay, you take this c to right side. Okay, you cubing on both sides. A plus b whole cube, which is equal to minus c whole cube. So we know a plus b whole cube formula, which is a cube plus 3a square b plus 3ab square plus b cube, which is equal to minus 1 whole power odd power is always minus, right? And c cube. You bring this c cube this side, which is a cube plus b cube plus c cube, and in the 3a square be 3ab square. What is common in this? 3ab is common, right? So you take 3ab common. A plus b remains a plus b, which is equal to 0. So we know this a plus b is equal to minus c. You substitute that a cube plus b cube plus c cube plus 3ab into, in place of a plus b, minus c. Okay. Now a cube plus b cube plus c cube minus 3abc, which is equal to 0, which is nothing but a cube plus b cube plus c cube is equal to 3abc. So this is our next identity. This is very helpful because if a plus b plus c is equal to 0, then a cube plus b cube plus c cube is equal to 3abc always. So this is one identity. So these are some different types of identity.